Okay, so here we are in number 4. They're asking us for the range and the interquartile range. All right, so this is actually really, really easy. So first off, a range. The range of the numbers is just the highest minus the lowest. You can put that in your 3x5 card if you want for the exam next Tuesday. Highest minus lowest. So what's the highest of all the numbers in the group of numbers here? 8, huh? 8 take away, so 8's the highest. What's the lowest of the numbers? Negative 9. So 8, double negative, right? There's the subtraction symbol, and then 9 is itself negative. Double negative is add, as you know, 17. And that makes sense, right? Because how far from negative 9 to positive 8? Well, there's 9 just in getting up to 0, and 8 more to get over to positive 8. There's 17 gap between them. The range is the gap, the distance between the high and the low, which is indeed 17, from negative 9 to positive 8. 17. So that's the range, which I already answered there. And what's the interquartile range? Well, I haven't told you yet. The interquartile range is Q3 minus Q1. You might want to put that on your box. Your 3x5 card, because that's the edges of the box chart. That's what's going on in my mind there. Interquartile range is Q3 minus Q1. Now, that means I got to find Q3, and I got to find Q1. Can you do that? Go ahead and find Q1 and Q3 for that data set. Rather than me just doing it real quick, I'll give you a second to do that. So find Q3, find Q1. Yeah, I did start 14.3. You guys are right. All right. So I'm going to go to fresh screen to get that rolling. All right. Find the interquartile range. So interquartile range. Interquartile range is Q3 minus Q1. So Q3 minus Q1. How do we find Q1 or Q3 or either one of those? What do we do? What's the first thing we do? Put the numbers in order. Remember, you got to have them in order to do Q1 and Q3. So to find Q1, order low to high. So you got to put them in order, low to high. So what's the lowest number? Negative 9. I'm just going to cross them off as I go. Negative 3, negative 2, 1, 3, 6, 7, 7, 8. Here we go. There's the numbers from low to high. Okay. And now, how do you find Q1? It's the P25, huh? If you're at the end of the first quarter of a football game, you're 25% of the way through the game, right? So remember, Q1 is 25. The median is the middle, halftime, 50% of the way through the game. And the Q3 into the third quarter is 75, P75. So P is 25. Well, so what? What's the formula? It's P over 100 times N. Remember that formula for finding Q1? P over 100 times N. Whenever you have a P, you can put it into the P over 100 times N. Put that in. So 25 over 100 times N. What's N? The number of data points, of data values. So what's the number of numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Did I do that right? 6, 7, 8. Yeah, 9 numbers. So N is 9 numbers. So if you do that, so 2.25. 2.25. Now, what do you do? Remember how this works when you use the P over 100 times N formula. What do you do when you get a decimal? Remember, we do one thing when we get a decimal answer and another thing when we get a whole number answer. Remember that? What do we do when we get a decimal answer? We round up. Remember, you round it up. And 3, but it's not 3, it's third. It's an ordinal. It's telling you what order. It's saying grab the third number. Grab the third number. What's the third number? First, second, third number. So the Q1 is negative 2. That's the third number, right? First, second, third number. That's the third number. Everybody good with that? Remember how that process works for finding a Q1? Let's find a Q3. So Q3, how do we find that? That's P equals what? 75, right? Into the third quarter, you're 75% of the way through the game. Again, it's P over 100 times N. So, I'm kind of running out of room here. P over 100 times N. So P over 100 times N, which is 75 over 100 times N. What's N? 9. It's the number of numbers. It's 9 numbers. So I don't know what that is. 27 over 4. 6.25? 7. Is that what it is? 7? 7.25? Did I have that right? 6.75. Oh, I'm just kind of guessing around here. I need your help there, Johnny. Thank you. 6.75. 6.75. 27 fourths. All right, anyway. And what do we do with it? Round it up, right? If it was a whole number, by the way, what if that came out a nice clean 6? What would I do? I would take the 6th number and the 7th. Average them. Add them and divide by 2. Remember that? Remember when it comes out clean whole number, you actually grab 2 numbers. That number and the next one. Add them and divide by 2. If it comes out a decimal, you round up and only grab the 1 number in that spot, the 7th number. Who's the 7th number? 7th is a 7, coincidentally. It's a 7. So Q3 is 7. Q1 is 2. All of that is for us to determine the interquartile range. Q3 minus Q1. It's Q3, 7, minus Q1, negative 2, double negative. Add 7 plus 2, 9. The interquartile range, the range between the quartiles, is 9. Remember, inter means between. What's in front of any word? Intersection, whatever. Means between. So it's between the 2 quartiles. 7 minus negative 2, add 2, 9. We good? That's how I got that answer. All good? I'm going to move on. Questions? All right. These on the next exam, a week from today. All right, so how do we find standard deviation? There's a whole process. Make a table, do all these steps. Here we go. Standard deviation. First off, what standard deviation is its average distance from the middle. Remember what this chapter is about. How do you communicate information about a whole bunch of numbers at once? Have you ever heard anybody give a standard deviation? What is it? So if you guys ask me, how did we do in the last exam, Mr. Heron? How did we do? If I said, well, the last exam, whatever, 25 of you, the average was 78%. Okay? And then, if I said, and the standard deviation was 10%. What that means is the average person was 10% off the middle. Deviation means, you know what a social deviant is, right? Somebody whose behavior is different than average, right? They deviate from normal, right? Social deviant. So my point is deviation means off the middle, doesn't it? Off the middle. How much does it deviate? How much is it different than the middle? Different than the average. So standard, like average, standard average deviation means average distance from the middle. So if I said the standard deviation was 10%, that means, 78% was the average. That was the middle score, maybe, on the exam. But not everybody got right in the middle, right? Some people got higher, some people got lower, and the middle was 78. Well, how much higher? How much lower? How spread out were they? Well, the average person was about 10% from the middle, either above or below. Now, in reality, some were way above the middle, some were only a little above the middle. Some were way below the middle, some were only a little below the middle. But on average, 10% from the middle was the typical distance from the middle. That's what standard deviation means. Average distance from the middle. Let me write that. So it means average distance from the middle. So it gives you a feel of how spread the data was. If I said the standard deviation was only 2%, that means everybody was right around that 78. They were all clumped in right around the middle. Hardly any deviation at all. If I say the standard deviation was 20%, that is a spread out group of numbers. There were some people that just bombed that thing. There's some people that got 100% on that thing. There was a big spread in the data. The bigger the standard deviation, the more spread the numbers are. That's what that means. That's actually probably a lot more important, the feel of it, than is any particular calculation. Because in real life, you'll probably never calculate standard deviation unless you do some statistics analysis. You might for crime reports or something in psychology or sociology or criminology. But if you don't, at the least, you'll probably all read reports or read information that gives you a standard deviation that somebody else calculated, and you'll want to know what that means. You want to be able to be an intelligent reader. Like, what does that even mean? They expect you to understand what that means. Yeah?
So if you're saying, like, if it was 10,
yeah.
it would be, like, 10% above 78, which is 88? Or would it be, like, 10% of, you know what I'm saying?
I hear you. It's that distance above and below.
With, like,
So if 78 was the average, that means there'd be a lot of people at 88 and a lot of people at 68 or around there.
Okay.
Does that make sense? Yeah, it isn't 10% of it. In other words, it is the actual 10%. Yeah, above and below. Yeah, that's what that would mean. It'd mean how far off the middle where they were, typically. You know, nobody was exactly 10% probably, but some were more, some were less. Yeah. All right, anyway, so how do we actually calculate it? Well, really, I just use my calculator and I hit the buttons. I would show you how, if we all had one calculator type, I would just do that. You write down those steps, and boom, you all do it on the exam. Do you want to come to my office hours? I'd be glad. There's only one left before, when's our exam? No, I'm Monday, Tuesday, Wednesday, 12 to 1. So I'm tomorrow, 12 to 1, and then I'm Monday, 12 to 1, and then I'm Tuesday, 12 to 1, and then we take the test. Oh, no, when's our test? Yeah, Tuesday. Yeah, so there's 3 more. Come by. Bring your calculator. I'll be glad to show you. I've done that for one student already. I'll be glad to do it for you. Every calculator is a little different, though, so I can't take time to do every calculator type. We won't get anything else done today. So if you don't, but it's not that hard to do it by hand either. But I mean, you still use your calculator, but I mean, there's a way to just like type in those numbers and hit do it, and it just does it. You don't have to add anything or subtract anything. So I'll be glad to show you on your calculator. If you want to come by office hours, but I don't have time in here now, so I'll just show you how you do it by hand. I mean, we're still going to use a calculator. First off, you list numbers. Let's do part B first, because part A is just 0. I'll explain why in a minute. Let's do part B. Part B, you just write down the numbers first off, 0, 6, 6, 12. And then right next to them, you're going to put the average. So first off, we've got to find the average. How do you find the average of a bunch of numbers? Add them up and divide by how many numbers, right? So the average will be 0 plus 6 plus 6 plus 12 over 4. What's that? 24 over 4, 6. So the average of those numbers, that makes sense, doesn't it? It looks like that middle is 6, doesn't it? 6 is the middle score. If this was quiz scores, somebody got a 0, 2 people got 6, and 1 got 12. What's the average score? Well, yeah, 6 is the middle. 6 is the average. Okay, what do you do? You subtract the average from each of these, and you get the deviation. That's the deviation, the difference from the middle. What is this? Negative 6, 0, 0, positive 6, right? So you see how we're getting the distance each score is from the middle right now? Right? The person that got the 0 is 6 below the average. The 2 people that got 6 are right on the average. There's 0 deviation from the average. The person that got the 12 is 6 above the average, right? So we're getting deviations from the average. And we want the what? Standard deviation, typical, average deviation. How do we do that? Well, you square them all, because you don't want the negatives in there. So square all these numbers. What do you get? 36, 0, 0, positive 50. Add them up. 72. So I just added up the deviations squared. Now, whenever you're we're trying to figure an average, right? I told you standard deviation is average deviation from the middle, average distance from the middle. Whenever you figure out an average of anything, what do? You add them up and divide by how many, right? Isn't that how we figure out any kind of an average? And a standard deviation is a special kind of average. So it makes sense that we're going to now add these up and what? Divide by how many numbers we got there, 4 numbers, right? And last thing, the one thing we did that's weird, that I would wonder about if I was you, I'd be like, why'd you square them? We did that because we want to get rid of the negative. But now we've got to undo that. What do I mean undo that? We've got to square root it. That undoes the square, sort of. So what is that? Then just hit the buttons on your calculator. Does that come out 4.243? Anybody get that in their calculator? 10 squared of 18. 3 squared root of 2. I believe it does. You guys getting that? Tell me yes, please. That's what I want to hear. Everybody get one of these practice exams?
Yeah.
Yes? Thank you. Anybody else not get a practice exam?
I'd be way back for that.
We good? You guys getting 4.243? Square root of 72 divided by 4? Just go 72 divided by 4 in your calculator, hit the square root button. Should be 4.243 rounded in 3 places. Have any trouble with that, come see me. So like I said, though, there's a way where you don't have to make any of this table for your calculators, where you can just literally just type in 06612, do it, and it'll jump right to the 4.243. But anyway, this isn't the end of the world, right? You could write this on your 3x5 card and follow the pattern on the test. Want to try part C? Let's do part C. See if you can crank that one out. All right, so try part C. These numbers. So you call them X or whatever you want to call them. 0, 12, 12, 24. Then you're going to have the deviation. No, not deviation, the average. Average comes next. And you got to find the average, right? So take the 0 over down here. You got to find the average. So you add them up. Right? Divide by 4. So find the average and then subtract the average from all of them. It's average 12. So subtract 12, and you get what's called the deviation. It's a lot like the last one, just double everything, huh? Getting that okay? And then compute the deviations squared. Square them all. Add them up. 288. Good to there. Am I racing ahead of you? And then what do we do with that 288? Yeah, because it's like an average, huh? So we add it up, and now we've got to divide by how many numbers and then square root it. So do you get the 8.485 thing?
Yeah.
And there we go. So that's not that bad, right? Just got to put that little table, maybe. Just put that one example right there. Just put it on a 3x5 card. Or come by office hours and I'll show you how to do it on the calculator. All right. Oh, and then part A is just 0. When you type them in, they're all going to be 0. Everything's 0. Because the average, what's the average of a bunch of 6s? Well, it's 6. That's all there is 6s. So when you subtract the average, they're all going to be 0 deviation. So everything's 0. You'll see. That one will be easy to calculate. And it makes sense, doesn't it? What is standard deviation? Average deviation. How much deviation is there when they're all the same number? There's no deviation. Right? That's like a society where everybody acts exactly the same. There's no deviation. Right? They're all the same number. There's no deviation at all. So it makes sense. Good? We good on that? Standard deviation. That way you don't have to do all 3 of them. I don't want you to do all 3 of these and waste a bunch of the hours of your life. Do part A, and then part B and C are the same. Why? Why would part B and C, why should you know, and this is the kind of thing it might be on the test. So it's not just important that you can make the table and do the calculation. Really, as I said, for the benefit to you, it's way more beneficial that you really feel what standard deviation is, because you're probably never going to calculate. If you do, it'll be on a computer, and you'll just type in the numbers and say, give me the answer. What's much more important is knowing what it really means. And if you know what it really means, you can answer. You'll know why B and C are the same. Think with me for a second. What's the difference between data set A and data set B? See how we've just added 1 every time? See how the only difference between A and B, all the numbers have just added 1. What if I said, hey guys, I gave a quiz to one of my classes, and here's the quiz scores they got. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I calculated the standard deviation, and it came out 2.872. What does that standard deviation mean? What does 2.872 mean? That means average distance from the middle, right? Average distance from the middle. So what if I told one of my classes, hey, okay, class, here's how you did on the quiz. You got these scores, and the average distance from the middle, like the spread, how spread out the numbers are. The average spread is 2.872, okay? What if I said, but I was feeling bad, like it was kind of a hard quiz, let's say, so I decided to just add 1 to everybody's score. So I added 1. This 0 became a 1, the 1 became a 2, the 2 became, etc. In other words, I got this data set. Did that change how spread they are from one another? Of course not. Not at all. Thus, the standard deviation doesn't change. Make sense? Because that just is a measure of the spread. You could add 1,000 to them all. You could say, I'm going to make this 1,000. This is 1,001. This is 1,002. Guess what the standard deviation would be? Same. Because that's just a measure of how they spread compared to one another.
And how did you get that answer?
Oh, yeah, I would just go through the table. So I went through the actual table. So I'm not showing all the work, but I just made the table. I would just go 0, 1, 2, 3, 4, 5, blah, blah, blah. And I would do average. What's that?
It's just from the information we already had?
Yeah, from the way we already did it. Yeah, that right? That makes sense? Everybody okay with that? I didn't show all that. The average would be 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. You add them all up and divide by, 10 numbers? What would the average be there? I don't know. Whatever. You get an average, whatever it is, 6, 10, 15, 21, 28, 29, 36, 46, 45, over 10, 4.5. So the average would be 4.5. You would subtract 4.5. Can I just go ... You would do all that work. It'd be kind of hard, with 10 numbers. It's a fair bit of work. And it came out to be 2.872. So that's why I don't want you to do it 3 times, right? Just do it once. That's how spread out the numbers are. That's the average distance from the middle in that data set. That's what standard deviation means, average distance from the middle. So therefore, if you added 1,000 to all of them, or added 1 to all of them, or what's this? This is adding 9 to all of them, right? Whatever, the average distance from the middle is not going to change, is it? So that's what they're testing if you really understand standard deviation. All right, one more, testing your real understanding. Good with that one? Does that make sense? So I skipped the work of Part A. You'd have to do Part A by hand if you don't know how to do it with your calculator. Yeah?
So if you ever had a set with one number, so when they're off by one number, it would always be 2.872?
Well, if you had 10 numbers, it have to be the same number of numbers also. If you had 10 numbers, all off by one number, yes. Okay. 2.872. Do you know there's I don't know if you've noticed that there's 3 kinds of average. There's 3 types of average used in society. One of them is the normal, the normal average, which is you add them up, to use bad English, add up, and divide by n, the number of numbers, right? That's one way to do average. Another way is median, right? We've done that a couple of times, median, right? That's the p equals 50. It's basically find the one in the middle. Median is find the one in the middle. They're both different kinds of averages. They're both ways of getting a feel for the middle of a big data set. Now, they work, why do we have 2 kinds? Well, depending on the data set, different ones work better or worse to truly give you a real-life sense of the middle. Median is the one you'll always hear about on the news whenever they talk about incomes or house prices. If you look on any housing thing, they always say the median house price, the median income in Fresno County, the median house price in Fresno County. They mean median P50. They didn't do the average the other way. Why? Median is really nice because it's not affected by super high or super low numbers. It just grabs the one in the middle. So in other words, what if I said, hey, in my neighborhood, the house prices are 200,000, and then 212,000, and then 213,000, and then 10 million. It's not really true, but let's just suppose that was my neighborhood, right? And I said, what's the average price in my neighborhood? Maybe there was some giant mansion on the corner, right? So what would be the average price in my neighborhood? Well, if you added them up and divide by 4, you'd get some pretty high average, like, I don't know what, 400,000 or something, right? See, that'd be really big because that 10 million would just bring it way up. But that wouldn't really. So if I'm thinking about moving to that neighborhood, what's the average house? That's about 400,000, 500,000. Thinking, really? Well, I can't afford that neighborhood. Well, that's not really the average. I mean, see how that's not doing a good job of the average? It's not really giving you a sense of the middle. Whereas if you did median, here, let's put one more in here. Let's say it's 199. Median, 1 divided by 5. What would be the median? Median's the one in the middle. Doesn't matter. You just grab this one, 212, average house price. And that's reasonable. See, it doesn't matter if this 10 million house is 10 billion. It doesn't affect the median. It would affect the add 'em up, divide kind of average hugely. But the median, the one in the middle, is not affected by super high and super low numbers. So in data sets that have really high and really low numbers, it does a better job of giving you a sense of the middle. So anyway, that's median. And then there's the normal average where you add them up. Lastly, there's a third kind. It's called mode. That's what we're looking at in this question. The mode. Hey, what's the average number of children per family in America? Is it 2? Is it 3? I don't know either, honestly. But I'm just playing around. Is it? I think if you figured out the average number of kids per family in America, it might be something like either 1.8 or 9 or maybe 2.1 or 2.2. I don't know. I'm just sort of guessing. Something like that. It probably wouldn't be exactly 2, would it? Wouldn't be exactly 1. Wouldn't be exactly 3. Now, why did you all say 2 or 3 instead of 1.8, 2.1? Well, because nobody thinks about part of a child, right? What does that even mean? 2.2, right? What does that even mean? Right, that's the very point. There's certain kinds of data sets where we don't want decimals. It's meaningless. So when we talk about the average number of children per family in America, we don't mean add them up and divide, right? We don't mean that. We just mean what happens the most, don't we? We mean, do most families have 2 kids, or is it 3, or is it 1? You know, what is occurring most often? Well, that is exactly what mode is. Mode is the one that occurs the most often. Let me get a fresh screen. I can write some of that out for you. That's the third kind of average, and you can see when it would be useful. Mode, the number that occurs the most often. Right? So average number of kids per family in America, you don't want to add them up and divide. You just mean, are there more families with 2 kids or more with 3? That's what you mean, right? Which one occurs the most? That's how you sense the average. That's called mode. How about shoe size? Another good example. Somebody said, what's the average men's shoe size? They don't want you to add them and divide. They don't want, 8.213, The shoe salesman at the shoe store would you mean, do you sell more 8s? Do you sell more 7s? Which one do you sell more of? He means the mode, right? Again, we mean the one that occurs the most. So sometimes average is best meant by which one occurs the most. So that's called mode. So there's 3 kinds of average used in society. So here we go. They're given this data set, and they're saying, what is the mode or modes? Which numbers occur the most? Remember what occur is? Frequency. That's how many. So that means how many 4s are there? 5 4s. There's 5 6s, and there's 5 7s. There's more 4s, 6s, and 7s than there are any other number. So actually all 3 of those are the mode. When you have tied for the most, you just list them all. So 4, 6, and 7 would all be the modes. They're the ones that occur the most in that data set. That's all you do. Nothing else on that problem. A lot of words for all that, huh? Is that good? Mode's cake. Just the one that occurs the most, or the more than 1, 2, or 3 that occur the most. All right. The mode of the data set. All right. So this is some kind of data. I don't even know what it is. Blah, 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 blah. They're asking me for the mode. Mode. So what does mode mean? The one that occurs the most. So you tell me, what section of the pie is the biggest? The purple section. Whatever that is. And that is Asian. Asian. Done. Next question. That's all you got to do. Mode is the one that... We don't care what the percentage is. We don't care anything else. It's the biggest. Mode is the one that occurs the most. The most of whatever that thing is measuring is Asian. That good?
I like those questions.
You like those? Lots of those. Please. 10, 15 of those on the next exam, huh? Okay. Mike's average on the first two exams in Econ 1A is 87. So what must he earn on the next exam to raise his average to 90? So if Mike got an average of 87 on his first two tests, how good's he got to get on the third test to have an average of 90? Well, you got the answers sitting there. How'd I come up with that? Well, if the average of the first two exams, it's like a trick question kind of. If the average of the first two exams is 87, you could just pretend that they're both 87. It's kind of like, even though they're not both 87, it's like they are because that's the average for the two of them. So just pretend the first two are 87. What does the third one have to be? I don't know. Call it X. So that the average, how do you average three things? Add them up and divide by 3. You want the average to equal what? 90. There's our little equation. We're going to solve that for X. See what I did there? I just called the third score X because I don't know what it is. The first two are 87 because that was the average of the first two. So 87 plus 87 plus, I don't know, X divided by 3. The average of those three we want to equal 90. So what does X have to be to make that average 90? We don't solve many algebra equations in this class. Here's our chance. What do we do to solve that equation? You remember algebra?
You have to put 90 over x.
Put 90 over x?
When you and them cross multiply.
Over x? You mean over 1? Anything alone is over 1, right? 90 is the same as 90 over 1, and then cross multiply. Diagonal, diagonal. So 1 times 87 plus 87 plus x is 3 times 90. Yeah, cross multiply. Remember that? Whole number just is over 1. 90 over 1 is the same as 90. Cross multiply, and then boom, boom, boom. That 1 does nothing. 87 plus 87 plus x. 3 times 90 is 270. 87 is 160, 174. Plus x is 270. Subtract the 174. X equals whatever that is. 96? Oh, yeah, that's why that's the answer. He's got to get a 96 on his third exam to make his average 90. Good? Wonderful? You good with that? Questions on that one? Okay, so I'm going to close that down.